Hi guys, welcome back to my YouTube channel, Mazatrol Tips and Tricks. If this is your first time here, my name is Phil and I teach people how to set up and run a Mazak CNC lathe while programming it with Mazatrol. If you guys have any suggestions for future videos or if there's something special you want to see, be sure to let me know down in the comments. In this video, I'm going to go over how to machine the uncut portion of a bar out process with a second tool. This is necessary if you're trying to machine a bar with a square groove shape and you need both left and right hand tools to finish the feature. Alright, let's get started. Alright, here's our part we're going to be machining. We're going to be doing a bar out process and we're going to be using a 35-degree diamond tool to machine this OD down to this face. But we need a second 35-degree diamond tool to machine on the back side over here. So this area is what I'm going to concentrate on in the program. So what we need to do is start and create a new program. So go to left button, program, program file, and we're going to select work number that's not listed here. We're going to use work number 80. So go back to program, work number 80. Input. If it's a new program, push the program button. Mazatrol or EIA, we're going with Mazatrol. Workpiece material is aluminum. Max outside diameter of workpiece is 3.25. Inside is 0. Workpiece length is 4 inches long. Max spindle limit, I don't want to run it past 2,000 RPM for the whole program. Finish allowance on X, 0.01, 10,000ths, and 5 thousandths on, actually 0.003 on Z, because I have the 93-degree lead angle tools and I don't want to machine as much stock off of. Stock removal of work face, I'm going to just clean up the face. So there's only about 5 thousandths left on the face right now, so 0.005. And the first thing we do is turn on the coolant. 3 arrows, M code, coolant on, down arrow. And now the next thing we're going to do, we're going to face off the 5 thousandths off the front with the edge process. Auto. And we're going to use tool 2, offset 1. Starting point on X is 3.25. And surface 7, and now we're programming the bar out. So what we're going to do is push bar and the open geometry out. Cutting point on X is 3.25. Cutting point on Z is 0. Auto for the feeds and speeds, but I'm going to reduce the depth of cut to 50 thousandths for this particular tool. And what we're going to do is program the chamfer here and the 3.2 inch diameter. So linear, 0.030, 3.2, and we're going to turn it back to 500 thousandths long here. And the next thing we can do, we can put a diameter all the way here with this starting point, and then it will create this geometry, but the tool will not be able to fit down into it. And because we describe the tool angles in the tool data correctly, the machine will not wipe out the part. And I'll show you that now. So linear, we can put a starting radius. Right here is 60 thousandths. Final point on X is 2.6, and it's got a 2-inch length on it. And the final corner is a radius 0.060 thou. Forgot to put a 7 in there. Linear. And we're going to turn it back about an inch, so about 3 inches long from the front. And we're going to put a chamfer up here of 30 thousandths. So 0.030, 3.2. And let's take a look at our figure. So now it shows exactly what we have on the drawing. We'll blow it up a little bit. So here's our drawing. Here's our part. But when I run the graphics, it's going to leave an uncut portion on the right-hand side of this. So program check, check continue. It's going to face the part off. And now it's going to finish the OD. But this is the area that I'm concerned about, is the non-cut area. So what we can do, there's 2 different ways to machine this. And I'll show you that right now. So go back to program. Get in back to edit mode. And right here, CNR is basically corner. And this shows what's going on with the uncut portion of this process. So this one will machine the stock out of there, and I'll show you that right now, but I don't like using it because it rapids down into the workpiece. It doesn't feed down into it. I don't know if they've changed that on other programs or controllers, but on this one, it rapids down into the material regardless of how you program. So push corner, out, highlighted. That should feed down into it, but it doesn't. So out, auto with the feeds and speeds. And then we're going to select tool number 3, tool data. So it's a general out with a 31 thousandths radius, and it's a right-hand tool instead of tool 2, which is a left-hand tool. And it's on the tool file, they're both a 93 degrees with a 35-degree angle on the insert, but because one of them is a right-hand tool, it's actually pointed to the right, and then the left-hand tool is pointed to the left. So 3, 1. So now we're going to do the starting point, and on the corner it's a little different than what a bar out process is. So on this starting point, we're going to give it a starting point down here of 2.6 inches and a starting point on Z around 800 thousandths because of how the previous tool cut this OD. Final point on X is going to be 3.2 because it's going to cut in this direction. And the final point on Z is going to be 500 thousandths. And then we can tell it that it has a radius in here of 60 thousandths. So push radius, 0.06. And figure check. And because it's drawing over the top of it, we're not going to actually see the corner geometry. Scale input. So now let's go ahead and run it. run the graphics again, the toolpath. So anything that's a solid line is a feed move, and it's feeding down into the material. Anything with a dotted line is a rapid move. So right now, it's making a dotted line, which is a rapid move down into the stock. And on the last pass, it makes a rapid move all the way down to 2.6 inches. That's the part I don't like about using it on this older controller. So it works, but you're rapiding down into the material at your finish X diameter, and you're not going to get a good blend doing that. So here's how I program. So program, erase. So what I'll do is I'll do a bar out process. Bar, not the highlighted one, but the regular one. So it rapids down into the material, and then I'm going to put an angle at the bottom to control the lead-in when it blends to the 2.6 inch diameter. So cutting point on X is 3.2. Cutting point on Z is going to be about 0.9. Auto, 50 thou, and then I'm going to use tool 3 again. So now what we're going to do, the first thing we're going to do is do a taper. And the starting point on X is 2.620. Starting point on Z is 0.9. And the final point on X, what I'm going to do is start here, and then I'm tapering down into this diameter, 2.6. And the final point on Z is I'm going in this direction, so the Z's get smaller than my starting point. Now what I'm going to do is do a horizontal line here with a radius at the back of it. So linear, 2.6, 0.5, radius, 0.06. So now what I'm going to do is I'm going to break this edge with the turning tool going in this direction. So we need to break that edge with a 30 thousandths. So put another linear, 30 thousandths, 3.2, and then I want to go past 0.5 by 30 thousandths plus 2 thousandths. So 0.468. 7, shape end. So let's blow this area up. That way we have more detail. And now we can see the 2.620. Well, let's blow it up real big. So 0.1. So right here, here's the line where it's going to feed into it and then feed across. So scale. And then also break that edge. So program, check, check continue. So it's going to face it off with tool 2. And then I'm going to leave this particular, it's going to cut a little more air than the corner process does, but it's going to feed down into it. And here's our overlap point right here. So now it's done. Now we just need to set the work shift and then run the part. All right, let's set the work shift. stop. We'll clean off 5/1000ths off of that face. We'll go program, program file, Z offset teach 0.005. That set our work shift. So now what we need to do is call up the program. Go to position, auto, work number 80, and we're 5/1000ths away from our part. And our trace shows our tool 5/1000ths away from the part. So we're ready to go and run this part. So right button, turn on the coolant, and let's go. All right, done roughing it. Now it's going to take the finish pass. Here comes tool 3. All right, now it's doing the finish pass. And we're done. 2 minutes and 1 second. And there's our part with a square groove cut in the outside diameter with 2 separate tools. If you guys like what you see, go ahead and push that subscribe button and click the bell so you won't miss any videos we have coming out. Also, if you guys have suggestions for future videos, please let me know in the comments. Thanks for watching.